Hello everyone, welcome back to the session. Now we will discuss about Benkelman beam deflection test. So the principle of Benkelman beam test and the procedure of determining the deflection value at any point of a flexible pavement will be discussed in detail. The Benkelman beam is the simplest and the oldest deflection test device developed in the United States in the mid of 1950s. It is used to measure the structural capacity of the flexible pavements. The principle says that the magnitude of rebound deflection of a flexible pavement when a standard wheel loads of a truck is moved forward is measured using Benkelman beam test. The test procedure covers the determination of a rebound deflection of a pavement under a standard wheel load and its tire pressure, with or without temperature measurements. So on the selected road stretch, a number of deflection observation points are marked on the pavement surface. The rebound deflection values generally vary from pavement to pavement, and the overall characteristic deflection value of the pavement stretch is estimated by statistical analysis of the deflection data collected. So this is the principle of the Benkelman beam deflection method test. So this is the diagram which shows the Benkelman beam. Now, let us discuss about the determination of the deflection values. So, we are supposed to drive the truck slowly parallel to the edges and then stop such that left dual wheel tires of rear axle is centrally placed over the first deflection measurement of the pavement. Then, second point says that this could be verified through the clear gap between the tires. The probe end of the beam is inserted between the gap of dual wheel and it is placed exactly over the deflection observation points. And remember, the rate of deflection is less than 0.025 mm. Then we are supposed to note down the initial dial gauge reading by D0. And then we will move the truck forward slowly through a distance of 2.7 meters from the deflection observation pavement point. Then the rate of recovery of deflection, if it is less than 0.05 mm, then we'll note down the intermediate dial gauge reading as DI. Then we are supposed to drive the truck through a distance 9 meters and then determine the DF value, that is dial gauge reading value. So after that, lock the Benkelman beam and shift the instrument to the next observation pavement. Perform the same test at 25 intervals on the either side of the road. So these are the diagram which shows the Benkelman beam deflection method test to be carried out on the field. Coming to the next slide, which explains some of the conditions here. So if DI minus DF is lesser than or equal to 2.5 divisions, that is nothing but intermediate dial gauge reading minus the final dial gauge reading. If it is lesser than or equal to 2.5 divisions of the dial gauge or 0.025 mm, then D is given by, it is 2 times of D0 minus DF divisions of 0.01 mm units. It can be also written as 0.02 into D0 minus DF mm. And the second condition is that if DI minus DF is greater than or equal to 2.5 division, that is nothing but intermediate dial gauge reading minus the final one should be, if it is greater than or equal to 2.5 divisions, then this indicates that the correction is needed for the vertical movement of the front legs. Therefore, the total D, the dial gauge reading, is equal to 2 into D0 minus DF plus 2K into DI minus DF divisions. Here, the K is to be determined for every trial of the Benkelman beam, and it is given by the formula 3D minus 2E divided by F, where your small d is the distance between bearing of the beam and the red adjusting leg, and small e, it is the distance between the dial gauge and the rear adjusting leg. And the last one is F, that is the distance between the front and rear legs. The final value of K of Benkelman beam, generally it is available in India, it is found to be 2.91, which is the average value of K. Therefore, the deflection value of D with the leg corrections, that is in case of B, with the leg corrections is given by D is equal to 0.02 into D naught minus DF plus 0.0582 into DI minus DF in terms of mm. So this is how the Benkelman deflection method test will be carried out to determine the values of the dial gauge with two given conditions. I hope you have understood the procedure and the determination of values. Moving on to the next one, that is falling weight deflectometer test. A falling weight deflectometer, it is known as FWD, is a device that is designed to stimulate the loading of a wheel passing over a pavement and measure its vertical deflection response to that load. The deflectometer, it is used by the civil engineers to evaluate the physical properties of the pavement. FWD data is primarily used to estimate pavement structural capacity for overlay design and to determine if a pavement is being overloaded. FWD data is most often used to calculate stiffness related parameters of a pavement structure. The process of calculating the elastic moduli of individual layers is a multi-layer system. For example, asphalt concrete on a top of a base course on top of the subgrade based on the surface deflections. This test can also be very useful in helping the engineers to divide the length of the pavement into homogeneous sections. Falling weight deflectometer can also be used to calculate the degree of load transfer between adjacent concrete slabs and to detect voids under the slabs. Here in this test, the sensors are typically geophones or force balance seismometers. In the area of non-destructive pavement testing, the FWD test has become a standard way of characterizing subgrade properties and assessing the structural capacity of remaining life of a pavement. So this is the diagram which represents the falling weight deflectometer equipment. Thank you.